Okay, so let's read problem number 1. A man of mass 80 kilos is at the elevator. He stands up on a weighting scale, and they're asking us to find the measure of the weighting scale if the elevator is, first of all, moving up, moving down, moving up with certain acceleration, moving down with certain acceleration, moving up with an acceleration negative, and he's moving to the 23rd floor, and also moving down with a positive acceleration. Okay, let's first draw the situation that they're describing on this problem. We have an elevator and a guy is inside the elevator. We also have a weighting scale. Now we know from the problem that the velocity of the elevator is constant, and therefore the acceleration is going to be equals to 0. Now, what forces are acting on the man that's standing on the elevator? First of all, the normal force of the weighting scale, and he's also influenced by the gravitational force of Earth. Okay, so from Newton's second laws of motion, we know that the sum of all the forces acting on an object is going to be equal to the mass times the acceleration of the object. So the forces acting on the person that's inside the elevator, as we said, is the normal force and the gravitational force. And we know the mass of the person, and as we said that the velocity is constant and therefore the acceleration is 0, this acceleration is going to be equals to 0. So the normal force acting on the person is going to be the mass times the gravitational force. So the answers for A and B will be answers for A and B will be mg. Now this is different for C and D, since they're giving us a value for acceleration. So what we need to do is calculate. So their normal force will be equal mg plus ma normal force. This is the answer for D. No, answer for C and D. Now we just have to substitute the values on the equation. For C, we have a mass of 80 times 10 plus 80 times 4. This is equals to 1,120 newtons going up. Now for D, we do the same. D is equals to 80 times 10 plus 80, but this time is going to be times minus 4 because the acceleration is negative. So as a result, the normal force is going to be 480 newtons going down.